Okay, we'll go ahead and get started here. So today's workshop is Slurm Job Management. So basically, we'll discuss a little bit more in depth the job scheduler that we use, Slurm, and some of the commands that you can use to run jobs, monitor jobs, that sort of thing. So first, I guess, what is Slurm? So Slurm is an open source cluster management and job scheduling system for Linux clusters, Linux HPC clusters. So basically, Slurm has three main functions. Helps to allocate access to resources. So that's going to be compute nodes. It's going to provide a framework to run and monitor jobs on those allocated nodes. And it also helps manage a job queue for competing resource requests. So certainly the discovery cluster is a shared resource. So there's lots of researchers submitting jobs. So you have to have some way to kind of manage that. Of course, lots of HPC centers use Slurm, but the configuration is going to be different for each cluster. So of course, we have our own specific configuration for CR clusters. And sometimes that gets changed from time to time. So it's not always permanent or set in stone. So things like job limits, for example, we might change around every now and then. If you want to get a lot more details than in this presentation, you can go to the official documentation website listed there. So to give a sort of brief overview of the Slurm commands, there's a bunch of them. You're probably familiar with some of them already. So basically what we'll do is we'll kind of go through each of these in a little bit more depth, but we'll spend a little more time on some of these than the others. And then as well at the end, we'll also talk about job dependencies and job arrays. So to start with, the sinfo command, this is just going to display some basic information about the compute partitions and nodes. So in this example, if you had your terminal open, connected to Discovery or Endeavor, if you typed in sinfo, you get some kind of a default output. So by default, this is going to list basically all of the partitions that we have. And it's going to basically sort this by partition and then node status. So you can see here in the terminal, I guess it lists not quite alphabetically, I guess by time limit here. It starts with the debug partition. So you can see there all the nodes are idle. Then it goes to the epic64 partition. You can see some of the nodes. There's one node in a draining state, one node in a mixed state. Other nodes are in an allocated state, and then some other nodes are idle. And that also, the node list also gives, those are basically the node IDs. So that's the default output. There's lots of different options that you can use with sinfo. So some of the more useful ones are the node, partition, or states option. So for example, if we wanted to only look at one partition, let's say 1 week, we could pass in this option, and then it only would output the information for that partition. So another thing to note, there are lots of formatting options for sinfo. So you can see here the formats typically in terms of the columns that show up here. So time limit nodes and so on. So I think with sinfo, the default output's pretty reasonable. But if you do want to customize things, if you go to the official documentation site, you can kind of look up some of the more formatting options that are available. And if you do end up, say, maybe you mess around with the formatting and you get one that you like, if you don't want to kind of always have to pass in this format option, you can actually set this environment variable sinfo format. You can export sinfo format, set it to kind of whatever format you want. And then you can add it to your bash.rc. So that way, every time you log in, you always get the same format set up. So then you can just type sinfo, and it will always use kind of your custom format options. So that can be useful. We also have a custom command called sinfo2 And this is just kind of a convenience command. The output doesn't look very nice there. Let me try to resize my terminal here. Hopefully it shows up okay. So what the sinfo2 command is basically it instead of the default where it prints it by partition and just node status, this will print it by partition, node type, and node status. And so this is useful because it'll give you some information about the different nodes we have in terms of the number of cores, the amount of memory, if it has a GPU or not. We also have the same information on our documentation page for the discovery resource overview. So this can be useful if you want to look at kind of the node types that we have, try to figure out like how many cores you can use, how much memory you can request, that kind of thing. So that's yeah, just kind of a convenience command. Ultimately, it's an alias for another sinfo command, but just makes it easier for you to enter that. So just to give another example, there's also, you don't have to use the long versions, you can use, say, the short versions of the options. So in this example, sinfo-lnp, the cap in, that's the node, so that'll be the node format. So basically that'll print out this format. This will print out the format by node instead of, so for each individual node. So you can see there, basically it does the node list for each node. And in this case, if you just did that without the partition option, of course, it'd produce a lot of output. So if you wanted to narrow that down to, say, just one partition, you do -p and then the name of the partition. This can be useful also. There's slightly different output here, but so this will give you, the state of the node, allocated, mixed, the number of CPUs, number of memory, kind of similar. And that SCT column you see there, that stands for sockets, cores, and threads. So for the first example there, I think pretty much every node has 2 sockets per node, so 2 processor sockets. And then there's 8 cores per socket, and then 1 thread per core. So that adds up to 16 CPUs. So there are different sort of codes for the node states. So as I mentioned, you saw sort of allocated, mixed, and so on. So the most common one you'll see are allocated, down, draining, idle, maintenance, mixed, or reserved. So if it's allocated, that means the entire node is being used. So every core on the node is being used. If it's in an idle state, that means no core is being used. And it could be that it could be immediately available to use, or sometimes even if the node is listed as idle, it's actually reserved. It's just waiting to kind of for a job to be scheduled for it, depending on how the job queue is. So you might not necessarily be able to sort of hop on a node automatically. Whoops. Sometimes you'll see the node state is either down or draining. Basically, that means there could be something wrong with the node. Maybe it's going into maintenance, something like that. And so in that sense, it would be unavailable for use. The mixed state, that's basically the node is partially being used. So some of the cores are being used, some of the memory is being used, but not the entire node. So we have configured Slurm, so you can, a node can share jobs. So if you have a 16 CPU node, you could have, for example, 2 jobs from 2 different users running. Maybe one job uses 4 cores, the other job uses 12 cores, for example. And sometimes the node state will be reserved. Occasionally we'll reserve nodes for classes, that kind of thing. There are other states, but those are sort of the most common that you'll see. Yeah. So draining, I'm not sure what definition I have there. Yeah, draining means not accepting jobs, and the jobs that are running on that node will finish. But then typically if it's draining, then it might go into a down state. It kind of varies. So yeah, sometimes another option, that states option, if you wanted to say get a list of all the idle nodes, you could just pass in this states option. That can be useful as well if maybe you're trying to decide which partition to submit your job to. So submitting jobs, so there's basically 3 commands. So sbatch for batch jobs, srun, which will be used for submitting parallel tasks within batch jobs, and then salloc for interactive jobs. And so we'll go through each of these. So starting with sbatch, so this is, of course, submitting a job script for remote execution. So if you have a job script set up, you basically simple sbatch and the name of that job script. And then if your job script is set up correctly, you'll get basically this output. It'll say submitted batch job, and then it'll give you the job ID. If there's something wrong with the job script, maybe there's a typo or something like that, or maybe the resources requested don't actually exist, then it'll give you an error message along those lines. So just sort of an example job script, relatively simple, kind of a multi-core job for running a Julia script. So the generic structure of a job script, so basically a job script is ultimately a special type of bash script that Slurm kind of interprets. So the first line of your job script will always be the hash bang and then bin bash. Then the next section is all these sbatch options. So the sbatch options are going to be where you're specifying primarily the resources that you're requesting. But there's also other options you can use, for example, to send email notifications, that kind of thing. But the ones you see here in this example job script, these are the most common ones you'll use. So nodes and tasks, CPUs per task, mim, sometimes mim per CPU, time, and then account. And then after that, typically you'll be loading the software. So whatever software program you're using. If you're using the modules, which probably most users are, you do your module load statements. And then after that, you'll, whatever command you use to run your scripts or programs would go next. Of course, this is a relatively simple example. You might have a lot of other stuff in there as well, but that's sort of the kind of basic setup. So in terms of the sbatch options, there's a bunch of them. So as I said, the most common ones are going to be nodes and tasks, CPUs per task, mim or mim per CPU, and time and account. So the nodes is going to be the number of nodes you want to use. So 1, 2, 3, and so on. So if you're not doing an MPI job, then you'll want to have nodes equals 1. In tasks, basically the number of tasks or processes to run. Again, typically, if you're not running an MPI job, typically that's going to be 1. And then CPUs per task, that's basically the number of CPUs, number of cores per task. And just a quick note there on CR clusters, CPUs, 1 CPU is equal to 1 core is equal to 1 thread. So sometimes you'll see those kind of terms interchangeably. So memory, there's 2 options. That's either mim or mim per CPU. If you're just running on a single node, typically it's easier to use the mim option because basically you can just specify the total memory that you'll use, say, 32 gigabytes, for example. You can use mim per CPU as well. That would be useful, especially for an MPI job. Sometimes you can use the constraint option. So if you want to use a particular type of node, again, so maybe use that sinfo command. If you want to use, say, a GPU node or something like that, or a very specific node, sometimes you can use that constraint option. Also, the partition option. So if you wanted to use, the default one is the main partition. But if you wanted to, say you're running a debug job, you could use the debug partition. So you'd add this partition option. Time option is going to be the maximum runtime. So however much runtime you need for your job. Account, again, that's the account to charge resources to. If you have multiple project accounts, there is a default account, so you just have to specify which account you want to charge it to. Another common one, as I mentioned, is these mail options. So mail type, you can specify kind of email notifications. There's a few options, but you'll probably just want to use the all option. So basically, if you supply the mail user, you supply your email address, basically that all option will send you a notification for whatever happens to your job. So typically, basically when the job begins and if it fails or when it ends. So at maximum, you'll probably get two emails. Sometimes you can also use these output or error options. This is if you want to basically customize the output file you get from Slurm. You can use these options. So as I mentioned, there are default values for these Sbatch options. So that's something to keep in mind. Not every option has a default value, but these options that are required will have a default value. So if you don't specify these values in your JavaScript, then the default value will be used. So for nodes, the default value is 1. For in tasks, it's 1. CPUs per task is 1. For memory, it's mem per CPU is 2 gigabytes. Time is 1 hour, at least on the main partition. I think on all the partitions it's 1 hour, but debug is a half hour. The default partition is main, and then the account, if you don't specify your account, it'll just use your default project account. And if you don't know your default project account, in the shell, if you type in my account, it'll print out some information there, and there'll be this column DEF account. So that tells you which project is the default account. So if you don't specify the account, basically that job, the CPU hours that you use for that job is going to get charged to your default account. So again, just something to keep in mind. And so if you only have one project account, you don't necessarily have to specify it. It'll just use that default account, so that's fine. But if you have more than one, it's a good idea to specify which account you want to use. So just some quick notes about submitting jobs with Sbatch. When you submit a job, if you're on the login node like I am right now, if you're doing some work, if you have certain modules loaded, if you've modified your shell environment, all of your shell environment in that login node is actually going to be transferred to the job when you submit. So that's something to keep in mind. Sometimes that can cause issues. So sometimes it's a good idea, for example, if you're playing around with modules, it can be a good idea to use this module purge command, because that will basically clear all your modules out. And then you can reset the modules. So in that example, JavaScript, for example, you can do module purge, and then you can go back and load whatever modules you need. So in the case of Julia, you have to load the GCC base module first, and then load the version of Julia that you want. Another useful option to use is if you set mem equal to 0, that will actually request all of the available memory on a node. That can be useful because maybe you just want the entire node and you don't necessarily want to look up what the value of the memory is. Another reason you might use that is because if we go back to this sinfo output, you'll see here for the 1 week node, all of these, or most of the nodes, have about almost 64 gigabytes of memory. So that's the sinfo will actually, so that is true. That is the amount of memory the node has, but we actually reserve some of that memory for some system overhead. So you wouldn't actually be able to request all 64 gigabytes. Typically, you'd have to subtract a couple of gigabytes from that. So you might be able to request you'd only actually be able to get about 60 gigabytes of memory. So that can be useful to use the mem equals 0 option in that case, so you don't have to kind of figure out like which exact value it is. Another thing to keep in mind for submitting jobs, if you're submitting jobs, especially if you're submitting a lot of jobs that actually don't take a lot of runtime, so say, for example, 10 minutes or less, it can actually be a good idea to actually pack all those jobs together into one job, because it could actually end up taking more time to schedule the job than it does to actually run it. So just, for example, if we go back to that JavaScript, let's say you're running Julia scripts, and maybe you have a bunch of scripts. Maybe they take less than 10 minutes. So instead of submitting multiple jobs, you can just add a couple of lines here that run more scripts, right? So Julia script.jl, add another line, Julia script2.jl, for example. So as I mentioned, so the job output files. So after you submit a job, by default you'll get an output log file, and that'll be saved to wherever you submitted the job from. So whatever directory you're in, where you entered that sbatch command, it'll look something like this. It'll be slurm-the-job-id.out. So that's the default value. So by default, any sort of standard output or error messages that you get from your job will be printed to that output file. As I mentioned earlier, there are these options, output and error. If you wanted to customize the file names, you could use those to do that. Or if you wanted to split up the output, if you wanted to have standard output go to one file, standard error output go to another file, you could do that with the error option. Slurm also has these file name patterns that you can use. They're kind of like these little codes here, like %x, for example, would equal the job name. So that would allow you to kind of automate sort of file names if you want. There's a lot of those options. So if you go to the official docs, there's like a table there that will give you all the different options that you could use. Another thing to note, that we do have job limits. So as I mentioned, the cluster is a shared resource. So we try to give all researchers a chance to run jobs. So we do impose some limits. So they differ by partition. There's different maximum runtimes depending on the partition. So the main and Epic 64 partitions have a maximum runtime of 48 hours. The 1 week and large min partitions have a maximum runtime of 7 days. And the debug partition, only 30 minutes. In addition, there's a limit on the maximum number of CPUs you can use at any one time. So on main and Epic 64, that's going to be 1200. 1 week 208, large min 128, and debug 48. Similarly for GPUs, on the main partition, 36, and on the debug, only 4. On the debug partition, we actually only have 2 GPU nodes, so there's not a lot there. And then even though you can only use, say, 1200 cores at any one time, you can actually submit more jobs that use more than, say, 1200 cores, but they'll just wait in the queue, and they'll just be pending. You'll get a reason, something along the lines of CPU limit. So you can actually submit up to 50,000 jobs on the main partition if you wanted. Same thing with Epic 64. On the other partitions, there's a lot less nodes, so those are a lot more restrictive. So 1 week 50 jobs, large min 10 jobs, and debug 5 jobs. So another thing that's useful is when you do submit jobs, Slurm actually creates these environment variables that you can use in your JavaScript or in your application scripts. So some examples of these would be Slurm job ID, Slurm job node list, Slurm in tasks, Slurm CPU split task, for example. So basically, these can come in handy, especially if you're kind of experimenting, kind of dynamically changing maybe the number of CPUs you're using, trying to find the optimal amount. That's something that you could use to kind of do dynamically. So in this example, something else you might want to do is just kind of document some of the job information in your output script. So in your job script, if you could add some lines here, like echo the job ID, for example, echo the node list to just document, which node your jobs ran on. And depending on like how you organize your jobs, maybe you have scripts in one subdirectory, maybe data in another. You can use that Slurm submit direct variable, and you can kind of automatically use some like relative file paths. So that can come in handy as well. These also come in handy for job arrays, and we'll look at an example of that toward the end of the presentation. Okay, so srun. So this would be for using, if you're running MPI jobs, so using multiple nodes, the srun command is basically going to launch the parallel tasks. So just to give an example of that in your JavaScript, so assuming you've set up your MPI program, you've used one of these MPI modules, compiled your MPI program with one of these modules, you would use srun to launch that within the JavaScript. And so srun is basically Slurm's version of MPI run. It's essentially optimized for use on Slurm clusters. So basically what that means is it compared to, say, MPI run, if you're used to using that, the jobs will be able to launch a little bit faster than you would get with MPI run. So there's actually a lot of options with srun. We won't go into too much detail about that. Sometimes, depending on which MPI implementation you're using, say OpenMPI versus MPI-CH, you might specify a different MPI value, for example. There's also options for task affinity. So if you do run MPI programs, if you go to our CARC user guide for MPI, there's a lot more in-depth detail about using srun and the options you can use there. So the other way to run a job is an interactive job. So that's going to be with the salloc command. And the options you'll use to salloc are very similar to Sbatch in terms of requesting resources. But instead of, you don't have a JavaScript, you're basically passing these options at the command line. So in this example here on the slides, you use salloc. If you just use salloc by itself, again, those default values would kick in. So by default, you'd get 1 hour of compute time, basically one core, 1 hour of compute time, and 2 gigabytes of memory. And so if you wanted to change those, basically you just pass these options. So in this example, request 2 hours of wall time and 8 CPUs. So basically, it'll give you some information. It'll say pending job allocation with the job ID. And then depending on how much resources you're requesting, it might grant you the job right away if there's an idle node that's available, idle resources. Otherwise, you might have to wait a little bit until those resources become available. But once those do become available, once your job is granted those resources, basically you'll log in to that compute node, and you'll notice that your shell prompt changes. So before you were on, for example, say Discovery 1, the login node, now it'll say your username at that node name. So in this case, D05-11. So interactive jobs are especially useful if maybe you're doing some interactive work at the command line, probably mostly for debugging work or just sort of developing scripts interactively. But once you kind of do your interactive work, maybe you're working in an R console or a Python console. Once you're done, obviously, if you hit your wall time limit, so 2 hours in this case, you'll be automatically logged out. But if you're done doing your interactive work and you want to get back to the login node, you can just type in the exit command, and that'll take you back to the login node. Oops. Okay, so those are sort of the 3 examples of submitting jobs. Once you submit a job, of course, you want to kind of, at least for the Sbatch jobs, you're going to want to get some status on what's happening to that job. So the command to use for that is sq. So the basic command is going to be sq and then -u and then your username. So if you use sq by itself, that's going to print out the entire queue. So that's that could be a lot of output, as you see here. I mean that certainly can be useful if you kind of want to see what other jobs are running. But if you pass in the username, basically that'll only show your jobs that are in the queue. And so there's for the default output format's pretty reasonable. Basically, it'll tell you what your job ID is, what partition it's running on, the name of the job, which is going to be basically the name of the job script. And then it'll give you this st column. So that's going to be the state of the job. And there's different codes that you'll see for that, which we'll get to in a second. And then you'll see the time column, which is basically how long the job's been running. Or if it's still pending, then it'll just have a 0 there. And then the number of nodes and the node list. So the common codes for the job state, typically you'll either see pending or running. So those are the two most common ones. So if the job is pending, that basically means it's waiting for a resource allocation. And there could be a few reasons for that, and we'll talk about that on the next slide. The other main one, of course, is running. So if the state is R, then it's running. So if we go back, so those first 3 jobs there are running. One job's been running for almost 20 hours, 2 jobs, almost 10 hours, and then 1 pending job. Sometimes you might see these other ones, either CD or CG or CA. Typically you won't see that. Basically, if the job is not running or pending, then it's probably not going to be in the queue. Basically, there could be like a second or two where it's either completing or it shows completed or canceled. So if you happen to submit that SQ during those 2 seconds where it's kind of finishing up, you might see those codes. So that is something to point out. If the job has finished, it won't show up in the queue. There won't be anything there. And you'll have to use, we'll get to another command later that'll kind of give us some output about that job. So if your job is pending, there's a few reasons that could be the case. The most common ones are these listed here. One is just the resources. So depending on what resources you're requesting, basically the job is just waiting for those resources to become available. And that's going to depend, it always depends on kind of like what other jobs are running on the cluster, how many jobs are running, what other resources other users are requesting, and so on. So if the cluster is not too busy, you should be able to get resources right away. It might take a couple of seconds just to kind of schedule the job, but it might start running right away if the cluster is relatively idle. The next most common one would be priority. So this is going to go back to that issue that the cluster is a shared resource. So your jobs do have certain priority values attached to them based on a few factors, and we'll talk about that in a second. The other common codes you might see are this requested node not available. Sometimes you'll see that that could mean that maybe the resources you're requesting, they're either not available, maybe because maybe they exist, but maybe that node that you need is down, for example. Typically, if you request resources and there's actually no node or nodes that could satisfy those resource requests, typically when you submit that sbatch command, it'll give you an error, and it'll say node specification does not exist. The other ones, if your project account, so the Qos Max Cpu per user limit, this goes back to those job limits. So if you're using more than 1,200 cores, you're submitting more jobs, basically your job will be pending with this reason. So basically your jobs have reached the maximum CPU per user limit. And then same thing for the GPUs. So it'd be be Qos Max Gres per user. That's gonna indicate that you've hit the GPU limit. And so basically what that means is, basically that job will start running, or the job reason will change. Maybe it'll change to priority once your other jobs finish. Once your other jobs finish such that you're below that limit, then your job state should change to something else. It might start running right away, or it might change to priority or resources, again, depending on whether jobs are running. Associated group CPU minutes limit. You might see this if your project account has run out of compute time. So each project account that you have, through that project portal, you request a certain amount of compute time. So if you see this, that basically means your project account has run out of compute time, and you'll just have to go back into the project portal, the user portal, and request more compute time. And sometimes you might see invalid account. Typically, again, if you submit Sbatch, you'll probably get an error right away. But that basically, that means there's a typo in your JavaScript. Maybe you spelled the project account wrong, something like that. So there's the most common ones. If you ever have any questions about that, feel free to submit a ticket if you're not sure what the code means, and we can help you kind of interpret what that means. So some notes for SQ. There's also a lot of other options to use with SQ. Also a lot of formatting options. Some options that can be useful would be like the partition. So maybe you don't want to look at the entire cluster. Maybe you only want to look at, for example, let's say the Epic 64 partition. You just pass in this partition option, and then you get a lot less output in that case. So most jobs do run on the main partition. So if you do use other partitions, it can be useful to use this partition option. So there's also the start option. So if you did SQ -u and your username and you added the start option, if your job is pending, if you give it this start option, basically it'll kind of estimate when your job will start running. It's not always accurate, but it'll at least give you some kind of ballpark estimate of when your job might start running. And typically it'll basically tell you the day and the time it'll estimates that your job will start running. So yeah, there's also a lot of formatting options, like similar to the sinfo command. I won't go into details about that. I think the default output for SQ is pretty reasonable, but there are a lot of other options. If you go to the official documentation page, you can get more information about that. And similar to sinfo, you can set this environment variable SQ format if you want to customize it. Another thing, if you get tired of kind of always typing SQ -u in your username, you'll probably be using SQ command a lot. So I'd recommend setting up this alias, some kind of alias that looks like this. You could just call it myq, for example, and then just set it equal to that SQ -u and then your username. So basically, you want to add a line like that there to your bash.rc file. And that way, every time you log in, this alias will be automatically set. And so just to give an example, I can type in just myq. I don't have any jobs running right now, so I don't get any output. But just, saves you some typing. Okay, so job priorities. So if your job is pending and it's listed as a priority, basically the way that job priorities are set is based on both a fair share algorithm that Slurm uses and the age of the job. So basically how long it's been in the queue. And so the fair share values, again, depend on a number of factors. Probably the main ones are going to be, how many jobs that you've submitted in the recent past, and how many resources you're requesting. However, it can also, the actual project account that you belong to can also factor into it. There is some weight to that. So if your project, if all of your project members are also running a lot of jobs, for example, that could penalize your jobs as well. Not to a great extent. It's not weighted the most, but it is a factor. So the fair share algorithm is a little bit complex. I won't go into details, but those are kind of the two main ways that the priority gets set. So there's a command if you want to get more information. It's called sprio. It can be a little bit difficult to interpret, but on the slide here, if your job was running, if your job was in the queue as pending and you wanted to kind of get a sense of what the priority is, you could pass in this sprio-j and then a job ID. Let me get this output to look a little bit nicer. Okay. So basically the default output is a little bit, hard to interpret. So basically you get this priority value. In this case, 1264, what does that mean? That can be a little bit difficult to interpret. So you get an age value of 70, fair share value of 5, for example. A better way to do it is to pass in this in option. So -in, the second example there. Basically that will normalize the value to a scale of 0 to 1. And so the main column really to look at here is the priority. So basically on that normalized scale from 0 to 1, if the job is closer to 1, that means it has a higher priority. In this example, the priority is really low. So in this case, say this user has probably been running a lot of jobs, maybe a lot of sort of resource intensive MPI jobs, for example. And so that's why the priority is pretty low. So sometimes, the sprior command can be useful. Again, if you have any questions about that, if you maybe you don't understand why your job is being deprioritized, again, feel free to submit a ticket and we can help you kind of interpret that. So if you want to cancel jobs, so if you have jobs that are pending or running, maybe you realize you made a mistake or you realize you need to change something, you can use this scancel command just to cancel your jobs. So typically you kind of do this on a per job basis. You just pass in the job ID, so scancel and then the job ID. Or if you wanted to cancel all of your jobs, you just pass in your username. So scancel -u and then your username. So nothing too complicated about that. Pretty simple to cancel jobs. Okay, so the next commands, stat and saccount. So these are going to be used for basically kind of displaying information about your jobs. So stat you'll use to display information about your jobs that are currently running. And then saccount is going to be used for displaying information about jobs that have already completed or failed, so past jobs. So both of these commands, stat and scaccount, the default output is not going to be as great as the other commands that we just saw. So these commands you're probably going to want to customize the format a little bit. So just to give an example of that, let's find a job that's running right now. I think I can run this. Let's take this job ID. So the basic command, if you have a job running, you'd be stat -j and then the job ID. Okay, yeah. So you actually can't look at other jobs that are running. You can only look at your own jobs that are running. So let me submit a job real quick. So if I submit a job, you can see the default output there is it gives you a lot of columns. And so, I mean, you can resize your terminal to some extent, but it's not going to look very pretty. But it gives you a lot of output there. It'll give you, there's a lot of different kind of columns and values. So if instead we can pass in, say, this format option here, I'll just copy this from the slide to kind of reduce the output. Typically, you only be interested in a couple of these values, depending on kind of what you wanted to kind of look at. So this example here, for this formatting option, I just want to pass in the job ID, these values here. So max RSS, average CPU freak, and then max disk read and max disk write. So the max RSS, so RSS stands for resident set size. So that's basically the memory use. Average CPU freak is basically how intensive your job is in terms of CPU use. And then maybe you want to monitor, say, IO input output. You can pass in these max disk read or max disk write values. So that's just one example. So obviously there's a lot of options there. So again, if you want to kind of look through all these options, if you go to the official Slurm docs here, it'll go through all the options you can use, and then you'll see there's this section here on the job, these job status fields that you can pass into that format option. So there's a bunch of them, job ID, again, max disk read, min CPU, all this stuff. So I'd recommend, so if you do want to use stat, again, it's only for running jobs. So once your job completes, you won't get any information there. So if I did this again, job completed, so there's not going to be any output there. So the other command is saccount. So this will give kind of similar information, but instead of for running jobs, it's basically past jobs. So it actually will give you some information for running jobs, but it's basically just, what state it's in. It won't give you any of the actual values until the job completes. So if saccount, if you just typed in saccount by itself, the basic default output, it's only going to give you back job information for jobs that have been basically completed in the past day. And the default output, there's also kind of a lot. You can kind of resize your terminal to some extent. But that the format is also something you'll probably want to customize with saccount as well. So there's similar information here. So this is the default output. If you only wanted to look at one job, again, you pass the -j option and then the job. Let's just say take the first one. And another thing that might be confusing here is there's actually kind of 3 rows here for each job. There's one row, and then there's another row with the job ID .batch, and then the last line, the job ID .external. So the main one that you'll want to look at is the middle one there, the .batch one. The first one just kind of gives you basically some basic job submission information. So basically the name of the job, when it was submitted, user partition, and then you can see that the allocated TRES there. So basically the resources that you requested. So CPUs and memory and so on. And it does duplicate that for some of the rows as well. But again, so in terms of the job resources used, so in this example, max RSS, so that was the memory used. Basically, you'd want to look at that middle line there. So the batch. This is the resources that are used during the batch job. In this case, didn't use much memory. That was just kind of a simple test job. So not much resources being used there. In this case, though, actually, this is a job that I had canceled previously. So you see there, the state was canceled. But in the other jobs above that, you see completed. If the job failed, it'll say failed. And then this exit code column is useful if your job failed. It'll give you an exit code and kind of give you a little bit more information about why the job failed. So first, we'll look at the kind of exit code in a second. But first, just some notes about saccount. There are some other options. So like I said, by default, it will only print out the jobs that have been submitted like in the past day. But if you pass in the start time option, if you have to specify it in the ISO format, so year, month, and then day. So let's say you wanted to look at jobs from the start of the month. Whoops, typo. Then you just pass in that start time option, and then you'll get a lot more output. If you wanted to say get a range of dates, you could also combine that start time with end time. There's also this brief option. So basically, this will only print out the job state. So basically, job ID, state, so canceled, completed, and the exit code. So that's useful if you just want to get, maybe you have a bunch of jobs running. You can just enter that in real quick, get a sense of after the job's finished, did they fail or complete. Also, the state. If you wanted to filter through, say, jobs that failed, or say, I don't have any failed jobs there, so let's just say state equals completed. Maybe I'm getting the syntax wrong. Well, maybe I'll have to look up the documentation. I'm not sure. It might want the short version. I'm not sorry, I forgot to look that up. But there's some command that you can kind of filter through with that. I don't know the exact syntax. Again, so you can also customize the format similar to the other commands. I think in my case, actually, I already set the saccount format with this environment variable. So typically, again, if you're probably be only interested in a couple of these format options, a couple of values to look at. So in this case, I had set my saccount format to these values. So if I unset that, it'll give me, I think it'll give me a lot more output, or actually less output. So again, if you don't want to always kind of be typing in this, format option, you can go ahead and set that in that saccount format variable. And then if you add that line to your bash RC, that'll automatically be set every time you log in. So just kind of a convenience thing. Okay, so job exit codes. So if your job does fail, so first of all, if your job is successful, if it completes, it's fine. The job exit code will be 0. So that's what you want to see. However, if it fails, it's going to be non-zero, but it could fail for a lot of different reasons. So there might be different options for that. Any number basically from 1 to 255. Basically, you'll just have to kind of look up what that exit code means, and then hopefully that'll be able to help narrow it down. But also that's, you'll basically check, if you check your Slurm output file first, that'll probably be the more useful thing to do. It'll basically give you, there'll probably be some error code in there. Maybe it's like an out of memory thing. So that'll be more descriptive in terms of debugging, why your job failed. If the exit code is either between 129 or 255, that means it was terminated by some kind of Unix signal. So there's a bunch of different signals there. Let's see, where is it? I guess it doesn't give the actual values in here, but again, basically, if you get a signal, something like 130 or something, you'll just have to kind of do a search and see what that signal means, and that can help you kind of debug. And again, if you have any questions about that, feel free to submit a ticket, and we can help you debug what that exit code means. Okay, so let's say that you ran a job and the job completed successfully. You can use this SF command to display some sort of basic job efficiency information. And primarily that's going to basically be CPU and memory use. So basically this is going to tell you kind of, depending on, say, how many CPUs you requested, how many CPUs did you actually use? Depending on how much memory you requested, how much memory did you actually use? So in this example here, basically the basic setup is SF and then the job ID. So this will return, some basic information. In this case, I guess this job used 1 core. It only ran, I guess, looks like for 24 minutes. So it looks so in this case, so there's the first 2 values here: CPU utilized and CPU efficiency. So this can be a little bit tricky to interpret, but basically the CPU utilized means the CPU was basically running for 5 minutes out of that 24 minutes runtime. And that could be for different reasons. It could be maybe that you requested, say, 8 cores, but your job actually only ended up using 1 core. So that might be a reason why you might only get a CPU efficiency, less than 100%, for example. That would probably be the most common option. Common event for that to occur. Another reason could be if your job is doing a lot of input-output. Technically, the CPU is idle during those times, so the CPU utilization could actually be less than the amount of wall time. So the next ones would be the memory. So similar thing. So memory utilized, memory efficiency. So first, the memory utilized. So that's basically tells you the maximum amount of memory that was used at any one time during your job. So in this case, 4.6 gigabytes. And then the memory efficiency basically tell you, what percentage is that out of the memory that you requested. So in this case, the job requested 70 gigabytes of memory, but actually only ended up using 4.6 gigabytes maximum. So this can be useful in terms of, again, job efficiency. So it can basically help you, one, it can help you optimize your resource requests, or two, it can actually help you in debugging. So in that first example, if you expected your job to use 8 cores, but it looks like it's only using 1 core, this SF output can kind of alert you to that. And then you can kind of go back and maybe make some adjustments to your JavaScript to kind of figure out, what's happening there. The other reason, so optimizing resource requests, the reason you might want to do this is because maybe if you're not actually using as much resources as you requested, the next time you submit this job or a similar job, basically it'll give you, if you request less resources, right, you'll end up sitting in the queue for a shorter amount of time. And so with this output, you can, let's say you only needed 1 core, you could reduce, your request from 8 cores to 1 core, reduce your memory from 70 gigabytes to say, 8 gigabytes. So basically that means your job will sit in the queue for a lot shorter time than if you had requested more resources. So that would be sort of the main use for this SF command. Another command that sometimes can be useful is scontrol. So this is going to be for displaying or modifying Slurm configuration or Slurm state. Typically, this is really used for admins, but there are some commands that can be useful for users. And there's some examples here. Some of the output is kind of similar to the sinfo command. So this first example here, so scontrol show partition. This will give you some information about a particular partition. So let's say epic 64 here. So the output is different. It's not column based. It can be hard to read, but there's a bunch of different values that are set here. So if you look at here, you can see for the epic 64 partition, we can see the default time is 1 hour. Max time, 2 days. Nodes, it gives you kind of a list of the node names and total CPUs, things like that. Another option that can be useful if you want to get some kind of detailed information about a particular node, you can do scontrol show node and then the node name. So let's say v22-01. This will give you some information kind of about the configuration of the node. So in this example, this is an epic 64 node, so it's got 64 CPUs. It's got 2 sockets, 32 cores per socket. 256 gigabytes of memory. And there's some of this, it'll also show you kind of the present state of the node. So in this case, I guess there's a job running. Looks like it's using all of the available memory. And so sometimes that can be useful if you want kind of, if you're trying to optimize your jobs to run on specific types of nodes, for example, you can use this command to get that detailed information. So you can also use this other option, scontrol show job. Again, this would, I guess, would be kind of an alternative to saccount. I think the job actually has to be running. Let's see if we can find one. I think I can run it. Oops. So this will give you kind of some basic information about kind of resources requested. So it looks like this job. So it's running on large min. It gives you the submit time, runtime, time limit, stuff like that. So basically, pretty similar output to that saccount or stat command, but just in a kind of different format. So, depending, I guess, kind of what output you're looking to get, you could use this command or the stat or saccount command. These other two options, scontrol hold and scontrol release. If your job is pending in the queue and maybe you realize maybe you made a mistake in maybe the application script, you can actually hold the job. So if you enter this command, scontrol hold, basically that'll pause the job. So basically it won't, it'll stay in the queue, but basically it won't be, it'll just basically get deprioritized. It won't get scheduled to be run. So if you, let's say there's something you figure, you make your adjustments to your script. Once you do that, then you can go back and do this scontrol release and then job ID. And then that'll put it basically back in the queue for it to schedule it to run. So that can be useful sometimes as well. Okay, so those were all of the basic Slurm commands. So kind of went through, talking about describing the compute partitions and nodes, how to submit jobs, how to kind of monitor jobs, get the job accounting information. So now we'll talk about the job dependencies, and then we'll also talk about job arrays. So these are kind of like special jobs that you can submit. So job dependencies, this is a job. If you have jobs that depend on other jobs, basically you can pass in this Sbatch option dependency, and you can defer the start of a job until whatever the specified dependency is, until the job will start running once that dependency has been satisfied. And so this can be useful if you have like workflows. So if you have kind of different kinds of pipelines, or if you have really long running jobs and you kind of want to split them up into separate jobs. And so there's a few different dependency types. Probably the most common one you'll want to use is after OK. So this first example here, dependency equals after OK, colon, and then the job ID. So basically, if you submit one job, you'll get the job ID from that. And then you have another, if you have another job script already set up, basically you do the Sbatch, add that dependency option after OK, and then add that job ID. Let's see if I have an example. Yeah. So in this example, you submit your first job. Let's say you're running some Julia scripts. One Julia script depends on another. You submit your job, you get that job ID. You have your other script already waiting. So basically you get that job ID, pass in this dependency option, and then submit the other job. So if you did that, in this case, if you did the sq command, you'd see, okay, your one job that you submitted is running, and then the other one is pending. I think there's actually a typo here. I think the job that's pending should be the JL2.job. So there should be reversed. Sorry about that. But basically one job will be pending and the reason will be the dependency. So basically that job will, once that other job that's running finishes, the after OK type, basically once that job finishes and it completes, meaning it completes with an exit code of 0, so it didn't fail for any reason, then the next job will automatically start running. I say automatically start running, it'll automatically start running if there's idle resources that are available. If the queue's really busy, it might change from dependency to resources or something like that. But it will be scheduled to run. So I think the after OK is probably the main one you'll probably use. You might use the other job dependency type after not OK. So maybe if your job fails, maybe you have another script lined up. Maybe it runs, I don't know, some debugging or I don't know, some kind of diagnostic code. You could use that one. There's also some other ones, after or after any. And there might be some situations where you'd use those as well. Maybe if the job is canceled, for example. So that's the basic setup for job dependency. And you can you can kind of get as complicated as you want with those. You can have chain dependencies. It just kind of depends on, kind of what you're trying to do. But yeah, so that's kind of the basic setup for dependencies. Okay, so job arrays. So a job array is another kind of special type of job that you can submit. And this is going to be for submitting, managing kind of lots of similar jobs. And it allows you to basically do this in a very quick and easy way compared to kind of manually kind of brute force setting up a bunch of different job scripts and application scripts. So the basic setup for this is you're going to add this array option to your job script, and you'll use some kind of index value, some kind of index range, for example. And basically, when you submit this job, it's basically going to submit the same job using the same resources requested, but it's kind of going to loop over and submit however many jobs you specify in that index. And so there's a lot of different ways that you can set up job arrays, and we'll just give one example here. But basically, what you'll have to do is modify either your JavaScript and or your application script to kind of use these index values. And so one common example where you might want to use an array would be if maybe you have a bunch of kind of input files. In this example, let's say you're using R and you're doing some data analysis. Let's say you have a directory of a bunch of, say, different data sets. And basically, you want to run the same exact script, but you want to run it on each of these different data sets. So again, you can kind of set this up differently. So again, if you wanted to do the brute force method, right, you could kind of set up different job scripts for each of these data sets, different R scripts for each of these, where basically the only difference would be the script you're running or the data set that you're reading into R. So what a job array allows you to do is basically get around having to do that, and you can kind of just do a little bit of basic setup, and it will automatically kind of loop through all of those data sets and submit those jobs simultaneously. So again, there's different ways you could set this up, but in this example, again, relatively simple setup. So for this array, so you're requesting for each job in this job array, this array is only, say, this is a simple example, so it's just an array of 1 to 3. So this will submit 3 jobs. Each of those jobs will have request 1 node, 1 task, 8 CPUs per task, 16 gigabytes of memory, and a 2-hour runtime. And so when each of these jobs gets submitted, it's going to run these same commands here. So module purge, and then module load. So in this case, just loading R. And again, this is, you might, for job arrays, this is where you might want to use those Slurm environment variables just for kind of documentation purposes. So each array job will have its own output file. And so maybe you just want to kind of include this echo task ID just to kind of document, which task was running. So in this case, the task ID is going to refer to this index value. So in this example, the array index is a range from 1 to 3. So there's going to be a task ID 1, task ID 2, and task ID 3. So in this case, so when job array, so when job step 1 runs, it's going to echo task ID 1, and then it'll run the R script. And so basically, in this example, just give a simple example from R. Again, let's say, this is an R script, you just want to read in some data, kind of process it, then model it. But again, you want to do this kind of for a whole set of data sets. So this example, let's say we're using the data table package. What we're going to do is basically we want to use that Slurm array task ID environment variable. We want to create basically a list of all of the data sets, and then basically we're going to use that task ID to basically extract one of those data sets and then run the script on that specific data set. So the setup is, okay, you load the data table package. First, you create a list of the files in wherever the files are. Ideally, say if you're looping over these files, so you'd want to basically have them in, say, some kind of data subdirectory. So in this example, as I mentioned, so again, so this is an array of 1 to 3. So typically, you're going to want to match that array index to however many, in this example, data sets that you want to run, whatever input files, for example. So in this example, let's say we just have 3 data sets. Maybe you have 200 or something like that. So basically, in this our example, so basically you create a files object that is a character vector of the list of files. So basically, it'll be a vector. It'll be the relative file path to dataset 1, relative file path to dataset 2, and so on. And so that'll be a character vector, with a length of however many data sets, so 3 in this example. And then again, we're going to want to use this task ID to extract one of those data sets and then run all of the different processing and modeling we want to do on that data set. So in this example, so in R, it's going to vary depending on which programming language you're using. But in R, the function is sys.getInvi. And so basically that's going to get the environment variable from the shell. So in this case, it's Slurm array task ID. In R, it'll return it as a character vector by default. So you wrap that in as numeric to convert it to a numeric number. And then you save that as a task object. So in this example, so for task ID, that's for the first one, task is going to be equal to 1. And so basically task will be set to 1. And then if you wanted to extract, the first, basically you set the index up. You say you create an object called file, and that's going to be set to the first element of that file's vector. And so again, that's going to extract that first element, that first data set path into this file object. And so if you wanted just to document, which file that actually was, you just print it out in R, you just print file, and so that'll print in the output file which file it was. So that's the basic setup for this. And so basically then so for task ID 1, then you get that first data set, then it's going to go ahead, okay, it'll use this fread function to read in that data, and then it'll go on, it'll summarize the data, process it, model it, and so on. And so again, so in this example, we have array 1 to 3. So when you submit this job, what's going to happen is it's going to submit 3 jobs. And for the first task, it's, this is going to read out, this is going to extract that first data set from the list. For the second task, it's going to extract that second data set from the list. From the third task, it's going to extract that third data set from the list. So again, there is a little bit of setup, but basically this helps kind of automate, submitting very similar jobs, but in a much easier and quicker way than kind of doing that in a brute force way. So if you submitted that, basically all you do is you just have one sbatch command. So you submit that array job. It'll give you an ID, but if you do the sq command, you'll see that there's actually three jobs running. And basically it gives you the job ID, and then it's an underscore and then a task ID. So again, depending on what index kind of value, what index range you've set up, it'll basically be the numbers that you give it. In this example, it's 1 to 3. So 1, 2, 3. So again, in this case, this example, there were resources available, so they just started running right away. So this is a relatively simple example. So like I said, this is only three data sets, but again, but if you're doing this for say hundreds or thousands of say files, then doing a job array is going to be a lot more efficient than kind of doing it the brute force way. So question, for job dependencies, do we have to submit one job first and then get its job ID and then submit the second job? Is there a way to kind of submit those two at the same time and specify which one? I'm not aware of a way to kind of automate that. There might be, you might be able to set up like some kind of bash script to do this automatically. But I don't think there's a way to do this in Slurm automatically. I'm not aware of one. But that's a good point though. Yeah, I'll try to look that up and see if there is actually a way to do that. I have seen examples of it using a bash, kind of using a bash script to do it. So I think it is possible, but it does require a little bit of setup. Yeah, so that's I guess the end of the presentation. So again, so for additional resources, the official Slurm documentation obviously goes into a lot more detail. Most of those commands, as you saw, have some kind of help. So if you're in the shell, if you pass in like the help option, for example, it'll print out kind of the different options that you can use with those commands. And basically the documentation page has the same information on Slurm's website, but it'll go into a little bit, it'll have a bunch of other stuff there as well and go into a little bit more detail. We also have some documentation pages. There's a guide for running jobs, which is basically similar information that's in this presentation. Although I'll also update that page to put some more information in there that was in this presentation. And we also have some JavaScript templates that you can look at as well. Yes, that's the end of the presentation. Are there any questions? Any like points of clarification? Yeah, so job dependency. Yeah, maybe there is a way to do it in Slurm. Yeah, I'm not sure. I'll have to look that up. Yeah, if I do find out, I'll add it to the docs page, and yeah, I can send you an email if you want. But yeah. And so there will be another presentation on methods for automating job submission. Part of that will be a little bit about Slurm, but part of that will be using kind of workflow programs. And Caesar is going to present that one. And I believe that's coming up on, whoops, where's the presentation? Where's the schedule? Okay. So that's coming up on, I guess it'll be a while. It'll be in April. So April 23rd, methods for automating job submission. So if you want to find out more information about that, kind of in more depth, a little bit more in depth than we did here, definitely sign up for that one as well. I think Caesar, you'll be looking at Pegasus software for submitting jobs. I think you'll look at job arrays and maybe some other application specific stuff like SnakeMake for Python, things like that. So if you're interested in that stuff, definitely register for that workshop. Getting this error, the debug partition. So the error there is the time. So the debug partition is only for, you can only request for 30 minutes. The idea there is just to have some, quick kind of debugging. I mean, if you are doing other kinds of debugging that you need more than a half hour, I mean, you just have to use the main partition, for example, instead of the debug partition, if you wanted more than 30 minutes. Or you might use like the 1 week partition, depending on how busy the main queue is. Okay, any more questions or advice or points of clarification? Okay, sounds good. So again, if you ever have any questions about Slurm, interpreting the output, stuff like that, feel free to submit a support ticket. We can help you with that. All right, thanks for attending. Have a great weekend, everyone, and we'll see you later.